Hey there, Math 8 students from Eveleth Gilbert Junior High. We're going to be doing some arithmetic sequences today. These are your notes for Chapter 9, Section 1. We're going to start off today's lesson with some vocabulary. Go ahead and pause the video, copy down the vocab, and then listen to the explanation. A sequence is an ordered list of numbers. When you were back in kindergarten, just a little 5 or 6 year old, you used to do sequences. You used to look at circle, triangle, square, circle, triangle, square, circle, triangle, square. So you used to do sequences with shapes way back in kindergarten. We're going to do those same kind of sequences, but now we're going to look at them just with numbers. We might throw in some variables in there, some letters, but for the most part, we're just going to be dealing with some number sequences. Each sequence is made up of an infinite number of terms. A term is just each of the numbers in the list. Okay, we separate those with commas. An arithmetic sequence is a special kind of sequence where each number, the next number in the sequence, is found by adding the same amount. So every time you start with the sequence, you add the same amount, add the same amount, add the same amount every time to go from one term to the next. In the definition here, it talks about two consecutive terms. Consecutive means in a row or in order. So if you subtract any two numbers in that sequence that are in a row or next to each other, they'll always have the same difference. Okay? That difference, that amount, is called the common difference. We're going to show that with the letter D when we write some equations. It's the amount that's being added in an arithmetic sequence. We do have this word up here, subtracting, add or subtract the same amount. Whenever a sequence is subtracting the same amount, we use a negative number for the common difference. It's showing that the sequence is actually decreasing. It's going down each time. We show that with a negative D value. Here's the first part of our notes. Again, pause, write this down, and then listen to the explanation. This is a general form for an arithmetic sequence. A sub n, these little numbers down in the bottom in the lower right-hand corner, these represent a subscript, okay? A subscript just means whatever term, specific term in the sequence that you're talking about. A sub 1 is talking about the first term in a sequence. A sub n just means that you would be talking about any number in the sequence. So it's the variable. So maybe you were wanting to find the 20th term. So it would be A sub 20. Or maybe you want to find the 100th term. So it would be A sub 100. So that little n down there just means that that would be the general equation. The n would be the variable in that equation. Again, this A sub 1, that's the starting term. That's the starting number in the sequence. Plus, and then we have our parentheses, n minus 1. Again, n would be the variable or the term you're looking for. Either leave it as a variable if you're writing equations, or plug the number in. If you're looking for the 100th term, put the 100 in there. Okay? The D, again, that's our common difference. It's the amount that's adding in between two consecutive terms. Again, if the term is a subtraction one, this D value will be a negative. Here's our first example. Again, pause it, write this down, and then I'll go through the explanation. So in this one, we have the instructions are to find the next three terms. So to find the next three terms, you're looking for the pattern. Okay, so in our pattern in the first one, we're going to just start by writing these little arrows underneath. Okay, the arrows underneath will guide us to show what's going on with that pattern. So the pattern here is it's a minus 5 every time. Every time you're subtracting 5 units to get to the next term. So our D value, this is an arithmetic sequence, and D equals negative 5 for this first example. Okay? To find the next three, we would just keep doing that minus 5. So negative 13 plus negative 5 gives us negative 18. Okay? Keep doing your minus 5 again, your negative 18 plus negative 5 is negative 23, and negative 23 plus negative 5 is negative 28. There's our next three terms. In the next example, we're looking for that pattern. So what's happening in between these terms? Okay, what is that pattern? So first of all, we're going to try some subtraction. When you try subtracting, these don't have the same constant difference there, that same common difference. So then try some dividing. In this pattern, you'll notice it's a positive, negative, positive, negative, positive. It's alternating back and forth between the positive and negative. When it's alternating back and forth, we're going to look at multiplying with a negative. In this case, it's a times negative 2, times negative 2, times negative 2, times negative 2. So we can still find those next three terms. 32 times negative 2 is negative 64. Negative 64 times negative 2, positive 128. And 128 times negative 2 is negative 256. This is actually an example of what's called a geometric sequence. A geometric sequence we'll get into later in the chapter, but a geometric sequence is found by multiplying the same amount in between terms. We call that value r. In this case, the r is negative 2. Like I said, we'll get into that in another lesson. Here we go with example 2 and 3. Again, copy them down and then listen to the explanation and write the notes as we go through. So the first one, write an expression that can be used to find the nth term. No, that's not a typo. It actually says nth term of each sequence. So this one, we're going to find an equation, and then we're going to write find what the 40th term actually is. We're going to start with our general equation. Remember I said a sub n equals a sub 1 plus n minus 1 times d. That's our general equation. We're going to put in the numbers that we know. We know the first term. Here's our a sub 1. So where it says a sub 1, I'm going to put in a 0.6. I'm going to leave the n as an n because we want to find the expression. I want to find what that equation is to find any term in the sequence. Okay? And the d value, we want to find what is happening in between each of these terms. So in this case, it's doing a plus 0.6. So that's a positive 0.6 for our d value. Okay? So this is our general equation. However, it's not simplified. So you have to go through and simplify this. To simplify, we have to get rid of these parentheses. To do that, we call on our old friend, the distributive property. So the distributive property gives us 0.6 plus, right here, 0.6 times n is 0.6n. Inside, we have the subtraction. Change it to plus the opposite. And now we have 0.6 times a negative 1. So that's a negative 0.6. Now we can simplify by combining like terms. If a sub n equals, here's a constant and here's a constant. They actually equal 0. That won't always happen. It did in this case. 0.6n. That is our general equation for this sequence. Okay? Now we can use that general equation to find any number in the sequence. So it's kind of like a shortcut method. Now we're going to look for what is the 40th term. So we're going to take this equation, a sub 40. We're looking for the 40th number in the sequence. Do 0.6 times 40. So a sub 40, the 40th number in the list, 0.6 times 40 is 24. That's the 40th number in the list. You could also take this sequence and write all 39 terms out and add one more 0.6 to get the 40th term. that's going to take you a while to write all 40 terms out. My suggestion, go with this equation and use that shortcut. In example 3, we're going to find which expression can be used to find the nth term in the following sequence. So again, we're finding that expression with the nth term. So we're going to find our a sub n equation again. So we've got a choice of 4 different equations over here. We're going to find which of these equations would work in this specific example. The first number gives you the position in the sequence. So that means this is our a sub 1, a sub 2, a sub 3, and so on. The term values are down here, 3, 5, 7, 9, and then a question mark because we don't know what the nth term is. So we're going to use that equation from the top again, our general equation. We've got a sub n equals a sub 1. A sub 1 is 3, so we've got 3 plus n minus 1. And then we want to look at what's the common difference. Okay, what's going on in between these? Each of these is a plus 2. So our d value is 2. So we're going to put a 2 out here for our d value. Using that distributive property, we get a sub n equals 3 plus 2n. You can either write it as minus 2 right here or plus a negative 2. Either way is fine. Combine like terms. 3 plus a negative 2 or 3 minus 2 is 1. So our general equation a sub n equals 2n plus 1. Because the n is a variable and 2 is the coefficient, that term doesn't have anything else that's like it, so we can't combine that with the other 2 parts. Okay, the other 2 are constants, so we put those constants together. Okay, this was lesson 9-1. Have a great day.